Hello and welcome to this the neural network. So today we'll be making a very simple project, air quality index prediction using machine learning. So it is a very means a small data set is there, very simple project is there, very good for understanding, means very good for basic hands-on practice, right? This is a regression problem, so we'll be applying linear regression, and this project will not be long. So let's begin with it. First of all, we'll make a collab file, Google Colab. We are doing this project on the Google Colab so that it is easy for you to also to try it hands-on. Okay, so we'll give the heading air quality index, that is AQI prediction using machine learning. Let us just copy it here. Next. Okay, so here we have it. First of all, let us see. So what is our objective? So in this project, we have to get the AQI, that is PM 2.5 data set, PM 2.5 value, based on the parameters. Those parameters can be temperature, humidity, these kind of things. So let us begin it. First of all, we will import the libraries. So import pandas as PD, import numpy as NP, and import matplotlib.pyplot as PLT. Rest of the further libraries we will be importing as we need them. As we go on, as per the requirement, we will be importing the further libraries. So we'll read the dataset df equals to pd.readcsv. I have to provide the file path location. Before that, I need to mount the Google Drive, give the permission to connect to Google Drive. So it is in the okay, it is done. When this drive folder comes here, that means that it has been mounted. The Google Drive has been mounted. Navigate to your project folder, and here is the data, aqi.data csv. I'll just copy it and paste it here and execute it. So this is done. Data set has been read. Let us see what we are having. df.head. So I have t, tm, t, small m. These values actually, see, these are the informations that are actually given to us. This will be given to us when we are given the data set. Now in this data set, I have it here, dataset legends. I have given the information in the folder that will be shared with you. So T means average annual temperature. TM stands for annual average maximum temperature, annual average minimum temperature, and so on, sea level pressure. If you want, for reference, you can copy it here also in the project. I seem to have lost my project. Okay, so it is open. I opened the Google Colab again. Just for information, for reference, for comfort, I'll paste it here as a markdown. So let us move ahead. First, we'll try to get to know our dataset. So df.shape. I need to know the shape and size of the dataset. So there are 1093 entries and total 9 columns, out of which one will be target variable. And in this case, PM 2.5. This is our target variable. We have to calculate the PM 2.5. This is what gives us the air quality, right? Air quality measurement, you can say. Let us see what are the columns we are having. df.columns. Same thing, not much. This columns, it will come as a list here. Next, let us go for df.info. We need to know whether we are having numerical values or not. So all the data types are of float type. So we are having all the numerical values. There are no object type data types. So we don't need to do much processing in that front. Okay, let us now see uh, df.describe. Yeah, so here, okay, df.describe. So we get the information here, the statistical information, like what is the count, what is the mean, standard deviation, minimum value, 25 percentile, IQ, this is 25 percentile, 50 percentile and 75 percentile. So we can see this and we can get the information from here. We'll move ahead to checking the null values now. So df.isNull.sum. See, in this dataset, we are having one null value and that is also in the target variable. So what we'll do, since it is a very small value, we'll just drop this one a single column, this single dataset. So let us do df.drop_na. And this I have to put it in df. So df has been changed to df.drop_na. Now let us check for the null values. It should be 0 now. Okay, so all the null values are 0. Let us check the shape also. See, now it has become 1092. What was it earlier? 1093. So one of the record has been dropped. Okay, so we'll remove this one. This is not required. This is also not required too. Okay, so now we will do the EDA, which is the exploratory data analysis. Let me put a markdown here. Checking for the missing values. And here we have to put explore. Now we are going to do exploratory data analysis. See, when we are doing actual project, so that time the data is new for us. So that time we have to sit down with the data set and spend some time with it. We have to check, we have to try to get insights from the data set. Okay, so let us begin. First of all, what we should do? We will check the distribution of the target variable. So what is my target variable? PM 2.5. So let us see how to do that. First of all, plt.figure, fig size. What it will be? Whatever size I want to put. Let me start with 4,4. Okay. Now, sns.histplot. I'll plot a hist plot. df of PM 2.5. I need the name of that column. What is that? PM 2.5. I'll just copy and paste it from here to avoid any spelling mistake. Kernel density KDE is equals to true. Why I am facing the problem? Because SNS is not defined. I have not imported the SNS library. I need to do it here. Import Seaborn as SNS. I could do it there also, but since the plot one I have imported here only, that is why I came here. I need to put the titles, that is plt.xlabel and plt. Sorry. So plt.title distribution of PM 2.5, right? Distribution of PM 2.5. Now let me execute it. I'll put a plt.show also. So, okay. So here we have it. So what are the observations I can do it make from here? See, the distribution is skewed. It is not a standard distribution. It is not a bell-shaped curve. And see, most of the observations, they are in the lower range, that is 0 to 100, right? Few extreme values are there like 400, 300. So that might be some outlier. It is possible that some outliers are there. And yeah, and the conclusion that yeah, it is not a normal distribution. So since we are suspecting outliers, let us check for it. Let us see whether we are having outliers or not. So to check for the outliers, we use the box plot. So let us see outlier detection through box plot. How to do that? plt.figure fig size. Why I am doing this again and again? See, when I'll tell you, initially I used to have a very difficulty in remembering these codes, remembering these commands. But since when you start doing it again and again, when repetition happens, that time your brain starts to retain these things. So more you practice, more you will remember, more you will retain. And practice means that you have to type it yourself. So let me plot the box plot. So sns.boxplot x equals to, again, what is your x? df of pm 1.5. Let me put the title plt.title box plot of pm 2.5, and finally plt.show. Okay, box plot is successfully created, and even though I am getting an error, plt.show, because here it has to be small p. Okay, still I got the box plot, right? Okay, so see, there are some outliers. We can means from the curve we can see that some outliers are there. So, but since see, these are actual values that that has been given to us, so we will not be dropping these observations. We will be retaining them for model training. Moving ahead, now we have to see one of the most important analysis that we have to do in EDA, that is called correlation analysis. Correlation analysis. So how to do that? Let us see. Again, plt.figure fig size for let me make it a slightly bigger, 6.6, 6. Now to see the correlation we need df.cor, and we have to plot the heat map. So sns.heatmap for what? df.correlation cor, annotation is equals to true, and we can use some cmap equals to coolwarm. Put the title to make it so that the presentation looks good, better for a good presentation. plt.title correlation heat map, and finally plt.show. Let us see if we get okay. So we have got it. Let us see. So what are the observations we can make from here? This PM 2.5, this is my target variable. So this one and this one, this line. Okay, PM 2.5. And here also PM 2.5. Okay. So let us see how things are. What are the observations we can make? Let us see SLP. So with SLP 0.62, it is there. And with the with this T, I think T was for temperature, I think average temperature, that is minus 0.63. See, these are some of the observations we can say, that it has strong positive correlation, positive correlation with SLP. We have strong negative correlation with T, and again with TM also we are having very strong negative correlation, and these are moderate correlation. So this figure, this helps us to make judgment, means how our target variable is changing in sync with means in reference to the dependent features, sorry, independent features, that is the features, simply features, right? Okay, so now let us move on to the next part, that is we will be separating the target variable now. So separating the target variable x equals to df of df dot drop. What you want to drop? Sorry. So what you want to drop? PM 2.5. PM space 2.5. Actually, it is better to copy paste. I am always comfortable with that. Okay, this one is fine. I think I have tried correct only, no issues with that. PM 2.5. And here I need to specify the axis, that is equals to 1. X is equals to 1 means you have to search it in the columns. And what will be the y? Y will be df of PM 2.5. I had already copied it. I got it here. So x and y are there. Let us see. X dot shape. I have 1092 and 8. And y dot shape. 1092. Okay, so now we have to move on to train test split. Let us see. So from sklearn dot model selection, import train test split. Now x underscore train, x underscore test, y underscore train, y underscore test is equals to train test split. I have to provide my x, I have to provide my y. Now test underscore size, I will take say 0.2. 20% will be my training data set. Okay, test underscore size will be 0.2 and any random state, random underscore state, let me put it as 0. That is fine. Let us check it. X underscore train dot shape and x underscore test dot shape. Successful. 873,219. So it has splitted into two dataset, that is training and testing dataset. So this is done. Now we can move on to train our model. This is a very simple project. I'll be only training two models. That is, I'll show you. Means first of all, we'll be using our linear regression, which is our baseline model, and then we will try it with one advanced model, that is random forest. Linear regression. So from sklearn dot linear model, import linear regression. Make an object lr underscore model equals to linear regression. And now we can fit on it. Lr underscore model dot fit. What I have to fit? Train and test. Sorry. Train and train. X and Y. I am training the model. Since I was going too fast, I am sure I made some mistake. I found one mistake, but see here. Still linear, this R has to be capital. This ION, okay, there. Still I'm having problem. Linear underscore model from sklearn dot linear underscore model linear linear regression. Okay, so I have it. My model has been trained. Okay, so model has been trained. What do you do now? You need to check it. Means okay, this trained model is there. The model means one mathematical equations has been prepared. Coefficients have been given to them. I need to see how are the predictions. So we need to do the prediction. Y underscore pred, and for what prediction will be done? For test values. Lr dot predict y underscore test, not y underscore test, rather x underscore test. Lr underscore model. I think Lr was capital. I need to change that also. Done. This is done. Let me see. So for the prediction, I am getting this all these values I have got as the prediction. 3, 4, 25. There are many rows. Okay. There are 219 values. Okay, good. So now I need to evaluate the model. Since there are too many, no, I can do this also. Just take the 10 values from the starting. Just for demonstration, so that because that data set was getting too big for presentation. Just for presentation purpose, I've only shown 10 values here. Our next job is to evaluate it. Means you send a person to learn something. He has learned it. Now he has come home. He will show his learnings, and then you will evaluate that what he has learned, it is good or not. So for that we have to do model evaluation. We will be using some metrics. Let us see how we can do that. Model evaluation. So from sklearn dot metrics import mean absolute error. I need mean absolute error. I need mean squared error, and I will be needing R2 score. Okay, so importing the libraries has been successful. Let us see MAE. So MAE is mean absolute error. Now, for what it has to calculate, test and predict y underscore test, y underscore pred. So this is done. Similarly, I have to do for MSE also. RMSE, just a minute. RMSE equals to mean squared error y underscore test, y underscore pred. I have to do the square root also. So here I have to add np dot sqrt. Done, successfully done. Not difficult, but requires practice and requires some understanding also. Okay, and R2 score. R2 equals to R2 underscore score, y underscore test, y underscore pred. So let us check it. Better to print it. So print MAE. My MAE is, sorry, not like this, comma, MAE. Okay, same way for RMSE and same way for R2. This is my RMSE and this is R2 score. No need for score underscore here. Okay. So these are the values. See, so generally what happens now, MAE, that is mean absolute error. So it is average prediction error. RMSE, root mean squared error, so it penalizes large errors. And R2 square, so it measures how well model explains the variance. So see R2 square, that is R2 square score, R2 score, this has to be higher, and this MAE and RMSE, this has to be on the lower side, means for a good model. In our case, from this what we can arrange, uh, we, we can conclude that see this R2 score is it is indicating it is not capturing all relationship in the data. Let us see how our different model performs. We'll see for random forest regressor. Let's see. From sklearn dot ensemble import random forest regressor. RF equals to random forest regressor. Let us see. Okay, no issues. Now we have to fit our dataset. So rf dot fit x underscore train y underscore train. That will be all. Now same way as we have done for linear regression, first of all I need to do the predictions. Let us see. Instead of lr.model, I'll just use RF. RF is my model name. Same way I will do calculate this also. Here actually I should have given it as y underscore pred underscore RF. Since I have already executed it, that y underscore pred variable has already been changed right now. So I'll just run this code again, all the codes again. Okay, now it's better. Now simply I'll copy this, I will reuse the code. No need to type this again and again. Here instead of ypred, I have to replace it by ypred RF. To print, I can reuse this code. See, so now the mean absolute error, initially it was 44, it has reduced to 20. RMSE it was 59, it has reduced to 33. And R2 score also from 49 it has gone to directly to 83. So now see, it has significantly outperformed our linear regression model. And only after we trained it on a different model and compared it with the baseline model, we see that okay, there is a lot of improvement in what is the difference, means how actually different model is changing the performance. So since this is giving us a very good result, we will be keeping this as our final model. In this random forest, there is one more thing that is that we do, that is called feature importance analysis. Now in feature importance, what we try to understand that which of the features had contributed most towards the prediction of the target variable. So let us see. Importance equals to pd.dataframe feature. Feature will be x.columns and importance. Here I will have rf dot feature underscore importances underscore. That is all. Let us see what we got. Okay, so we have it, feature name and the importance. We will sort it. Dot sort equals to importance dot sort underscore values by importance and ascending is equals to true or false. Ascending equals to false because I want it in descending. Now let us print it. See, so T was the highest contributing factor in the highest contributing feature towards the prediction. This is the conclusion we can make from here. So this is a very important analysis that has to be done. We can also visualize it. We can also plot a graph for it. Generally, let's see how to plot the graph. Visualize the feature importance. Same plt dot figure. Fig size 4,4. SNS dot bar plot. In the bar plot, simply data is equals to importance. And x is equals to importance. And y is equals to feature. Plt dot title. Feature importance. Random forest. And finally we'll do plt dot show. Okay, there seems to be a lot of errors. Let us see. SNS dot bar plot. Rectangle set got unexpected argument because I put here x as capital. Wow, just because of that capital and small, the whole curve was not getting plotted. Okay, so we have it. See, this is very good representation. Like this is contributing significantly, and rest all the contributions are slightly lower compared to the t. Okay. Okay. So since it is done, we have finalized our model. We will finally save our model. So save the model. How to do it that? We will save it through pickle file. So import pickle. Okay. Now see the commands with open AQI underscore RF underscore model dot pkl. I have to give it in quotes, comma WB means write binary as F. Pickle dot dump RF comma F. This is done. WB is not defined because I have not put it in quotes. Let's see whether it works or not. Runtime disconnected. This should okay. It is done. I think there was some issue with my connection, so that's why it got disconnected. But anyway, it is fine. See, so our model is saved now. This was a very basic problem. We have not taken very complicated problem in this, so that is why I covered it in this single video. It is about 40 minutes long. I do hope that you'll get some good insights from it. See, what happens that solving these kind of easy problems only will polish your hands. Means it will polish your skills to make new projects. So do let me know if any improvement is required from my end, and do let me know how you liked the video. Please do evaluate my performance also, so that I can make corrections, I can make improvements. And if you have watched till here, thank you very much for watching. So let's see, let's meet. Thank you.